So the previous two sessions, we have come up to our understanding of Kubernetes cluster, what is inside the slave nodes, the components, and what is inside the master node. So we have learned about kubelet, kubeproxy, and we have learned about scheduler, controller manager. We have learned about HCD APIs. Okay. So today we are going to start with the understanding of the pods. Just now somebody has asked me about container, Docker, containers. Now, of course, as we have explained earlier, we were very sure that both our master plane or the control plane, the master node, as well as all the nodes should have the Docker or any containerization tool installed on each and every node on each of the master node. Because without container, the CRI, container runtime interface, without that container interface or runtime, you will not be able to work with the pods. Why? Because pods are nothing but, let me make the screen bigger. You are being able to see this term called pod. And we are going to learn the pods. Pods make the availability of the application contained in the multiple containers within each pod by replication of each pod into multiple copies in the same virtual machine or distributed in separate nodes in the same cluster. So in simple terms, it is like a container. A container is having an image. Image is what? An application. The microservice application that we are talking about. It's a Java application or a .NET application or any perceivable application, Python, PHP, okay, C hash, whatever is the application. So that application in form of a microservice is available inside a container. And then you do something to make an abstract layer on top of the container. Now you can ask me why a raw container is not sufficient to be deployed on in a cluster like Kubernetes cluster. The answer to it is because the containers will have ports. The containers have ports, but there is no port communication because you can think of communication between the containers will happen through the ports, and there can be hundreds and hundreds of containers in the cluster. So a port communication between each and every other container is quite a complicated architecture, like what we used to do in the Docker Swarm network. So your networking has to be, you have to be very good in the networking concepts. But it is not possible for all the developers to have a very good concept in networking. And to create a cluster of such network where each of the containers communicates to each other in a swarm network is quite difficult to implement. So what they have done, they have put the container inside a pod. So a pod is an abstraction layer created over on top of the container. Why? Because a pod is created with an IP address. And it is very easy to communicate between the two pods through IP address communication. That is the basic communication. That is the easiest mode of communication. You cannot communicate. You can communicate, but through port communication is quite difficult. So pod is basically the smallest unit of Kubernetes cluster. It is an abstraction over the container. Abstraction is a object-oriented programming concept. That means you put an abstraction layer on top of container because as if the container is embedded, it is an embedded sort of a concept. The container is sort of secured or embedded within the pod. And the pod will be the layer which will communicate with the container through some mechanism that we are going to discuss. And generally the thumb rule is always you have one microservice or one container inside one pod. There is, of course, theoretically, you can have within one pod multiple containers, but that is not the good design. Your architect will never go into that design to save. It is very, very bad architecture when you say, I will include two containers in one pod. No, don't do that. The pod mechanism is simple. So create a pod per container because you want to embed one application within one pod only. And between two applications, you communicate over the IP address of the pod. So that is what, and this pod is developed through the deployment. Deployment is a manifest file, okay, a Kubernetes object. So one object, a deployment manifest, will create a pod, and therefore you can define something called your resources for the pod. You can say how many CPU, how much of memory will be allocated to each of the pod can be assigned some resources. Similarly, when the deployment manifest file is executed over the Kubernetes cluster through kubectl, remember we have discussed about kubectl, we have discussed about kubectl. Kubectl is a CLI, Kubernetes CLI. Okay, that CLI will give instructions, and with that instructions we will execute a deployment manifest file, which is nothing but a code, a Kubernetes code, which will be executed through the API server. You know that API server, the pod, which is in the master plane. So the API server will execute the deployment manifest file through the kubectl command that you are giving. And that will produce what? This is the process, and that will produce what? When you execute the deployment manifest file, it will produce a replica set of pods. Let's say this deployment file has 3 replicas of a particular application or a pod. And what is that replica set? 3 replica sets. So I have created 3 pods, pod 1, pod 2, pod 3. When I execute through the kubectl command to execute this deployment manifest file, I have created, because I wanted 3. If I wanted 5, I will make that provision inside the deployment manifest file. That is my command file or the configuration file or the manifest file that I'm going to execute, and that will be processed through API server. And API server will create. Now tell me, these pods, will it be on the master node or on the worker nodes? So each can be distributed. If there are 3 nodes, because pods are always created on the nodes, on the worker nodes. It may happen that these pods can be, who will create those pods? Which component of the master server will create or do this pod creation? Anyone? API server is the main controller, which will help to execute or process the deployment manifest file through this command. Yes, but who will actually be behind creating of these pods and scattered over 3 nodes? Maybe the sequence is 2 in one node, 1 in another node, and 0 in the third node. So no nodes have been created. Or it may happen that it has decided that it will distribute like 1:1:1 on all the 3 nodes. Or it may also do like this, 3:0:0:0. It may happen. This can be a lot of permutation and combinations. It depends on whom. What is that component who will take care of see all the health of the nodes, how busy are they, how much resources available, whether I can fit in two, or I can only fit one, or I may not be able to use that node. Who is going to take that decision? Can anybody help me answering this question? API server does not do anything like your managers. Managers do not do the work themselves. They will delegate the work to somebody. And who is so? This API server is the main manager. API server. So to whom this work of creating those nodes will rest upon, will be delegated to? We have discussed the architecture. So what? Who is that person? Who is the component? What is the component with which API server will instruct or delegate the job of creating or creation of those pods over on the nodes? Is it not the scheduler? Right? And the scheduler will in turn take the help of what? Controller manager. And the controller manager will take the help of, because there was a replica set, okay? So controller manager will call whom? Replication controller. Replication controller and another one. Can you tell me? Plus node controller, because it has to distribute the pods over the nodes in the cluster. So node controller. But they are the sub services under whom? Under the controller manager. So actually the work is being done by scheduler, but scheduler is taking help in turns with either replication controller from the controller manager or the node controller and the node controller maybe. So that way, with the help, this is a synchronized process. They are working in a well-oiled machine as a well-oiled machine, and they will finally end up creating replicas. 3 replicas one was asked for, desired for, and 3 replica of the pods are created. Each of these pods will be created over the pod network. This API server is a pod. It will communicate with this pod over a pod network. So there is either a Calico or a ViewNet. We are generally learn the ViewNet pod network. That is the backbone on which our pods will communicate with each other, pod network. And the pod network is also now, there is a component called kube proxy, network component. So that network component kube proxy will interact with the pod network, and then it will interact with the kubelet. Kubelet resides over here on the node. Kubelet is the pod manager. So they are all managers managing specific activities. Okay? And the advantage of that, because each of these pod will have an IP address. So IP communication is enabled. Because now you have not a container only, you have deployed pods. So this is a container, and this is included within a pod. This is container, and inside the container, what is there? There is the image, the application itself. This is the image. And this is the pod. Okay, the abstraction layer on top of the container. And the container is containing the image. So once the container runs, that means you are running the image, the application. Okay. So usually I will have one pod, one container, one application per pod. Each pod gets its own IP address. So you see, you got every pod will have their own unique IP address. You cannot have duplicates. No, that is internal. So this is a pod. You can give it any name. So labeling is very important. And this is the container inside the pod. The container will have the application. These are the microservices. The application contained by the container. This is another container. This is another pod by the name DB, database. This is a database application. This is a front-end application or a back-end application, whatever application is. So maybe this is a login application. Login microservice application, login application. And this is a MySQL server database. MySQL database. Whatever database. So both will communicate through the IP address. But one thing, pods in Kubernetes is ephemeral. Anyone? Please help me with understanding of this term, ephemeral.
It means it's short term, right?
Yes.
Ephemeral.
Very
temporary.
Very fantastic. It is temporary, ephemeral. It is not permanent. So it is not like a server that you have created your server and that server is going to run. No issues. These are objects. These are container objects which may or may not be available all the time that you need. And that is a hard reality. So there is a risk of the pod getting, it can die easily. Therefore, the pod will be replaced with a new pod assigned with a new IP address. So see, let's say this application pod has gone down. So do you think when this pod is replicated or replaced by another pod in its place, will you have the same IP address? No, naturally no. Random, a new IP address will be created. New IP address. Very natural. You cannot have the same IP address. So you do not have any control. There will be a new IP address created along with the new pod. So what is the adjustment that you have to do? You have to again establish a connection with because this IP address knew that if I want to connect to this particular pod, I have to use a particular IP address, but the pod has gone down. So there is now a new IP address. So this communication has to readjust. And this readjustment is very, very resource hungry and time consuming. It can be time consuming because you are not dealing with only two pods. Here, for the sake of our simplicity, we have drawn two pods, but in a enterprise level of clusters, you can have around 1,000 pods. So, and it is not possible for you to keep on readjusting because 1,000 pods at any point of time, any pod, any number of pods can go down and getting replaced with a new IP address. So every time your main task is only getting readjusted. Is it good? Is it good for the health of the system? Your communication has to readjust itself with the new IP address that has been created. Is it good or bad? Very bad. Bad means it is not desirable. It is going to have a impact on performance. it is very difficult to monitor the health. And if the network or the communication cannot adjust in time, and so there can be a loss, a leak of data. So there is a user experience. The question of user experience comes into thing that they are not going to get a reliable data service, or the data is not reliable because they may be seeing there is a thing called dirty read. Dirty read means during some update is happening, say there is a database update. So what will happen at that point of update? You are actually reading the old data. That is called the dirty read. So if at that point of time you need to get the latest data update, you have to have the minimum latency between the update and the read. So the main challenge is to minimize the dirty reads. And that cannot be possible if you communicate over IP address. There will be, even if it's the slightest of contingency or slightest of latency, will always be there. So when you are communicating within 1,000 pods, you never have any control over the dirty reads. It is a bad performance and reliability issue, or user experience can be very bad. So the scientists working on the Kubernetes cluster and with this containerization mechanism, they thought of something called service. Instead of IP address, let us use a communication through the service. And once you have created a service, now service is an object. Like your deployment is an object, your pod is an object, deployment is an object. Similarly, your service becomes an object. An object will have a permanent IP address. That means what does it? How does it differ? Let's say your pod has gone down. Your service do not get down along with the pod. That means your IP address will remain the same. Do you agree? So the communication between these two IP addresses will always remain the same. Do you agree? Because service will never die, even if the pod dies. So the same service will be attached to the new pod that has been replaced, that has been replacing the old pod which has died. Because replica means you need to, I need a replica of 3 replicas of the pod. Let's say the pod is my app. I want my app 3 pods, replicas, same clone. So if one goes down, it will become 2. Because I desired 3 replicas, so every time the 2 will be again replaced by 3. So 1 will be added. 2 plus 1 will be immediately added, making it 3, because you desire 3. So the new pod that has been created will again be referred with the same service. We will come to service. Why you create a pod over a container? Because you need the IP address communication. Then why you create service to relate or to refer to this particular pod is because you cannot rely on IP communication because the pod can die anytime. With a new IP coming, we have to readjust the communication between the pods. So therefore, I have devised a mechanism where I will be relating to the service attached to every pod with the same label. So the service will be actually is not dependent on the IP address of the pod. The service is actually related to the label of the pod. So one pod dies, another pod with the same label will be created. So this service will be attached to the same label. This service cannot be attached to this because this service is attached to this label of the pod. So they are two different objects. This is a different object having a different IP address. So whenever you refer to this service, it will take you to this pod. Somebody has to take you to this particular application. That is, you are using a URL from outside. You are using your laptop and you are using a browser and giving a particular URL. That URL is going to be hitting this service through some mechanism. And this service, because you wanted this application, DB application. So this service, you have to hit this service to reach the endpoint. This is the endpoint. So therefore, you will be seeing the data provided by this particular database application. You want to access this particular application, login application. So you have to hit this particular pod. So you need to attach, you need to refer to this service. This service will take you to this particular pod. So since your IP address will never change, so you will always go to this pod, any one of these pods, any one of the replica, because they are clones. Your purpose is solved. So you see, pods in Kubernetes is ephemeral. That is, they can die easily. Therefore, the pod will be replaced with a new pod assigned with a new IP address. Hence, the internal IP address communication between the pods will need to be adjusted every time the pod restarts, right? Because it's a new IP address. So you have to, your network has to readjust with the new IP communication. Hence, there was a requirement of creating another component of Kubernetes called service will be used instead of replacing the IP address of pod. So instead of, so you have replaced the IP address with the service. Service has internal, service has internal IP address. And this IP address will never die unless and until you kill this service. If you make this service, if you drop this service or kill this service or delete this service, then only this particular IP address will be removed. Otherwise not. Because it's an object, you can play around with this object. So
Yeah.
what is, please go ahead.
Yeah, in single pod, you said, right, only one application we have to deploy, or can we deploy more than one application?
Yeah, you can, theoretically, it is very much possible to deploy more than one microservice or more than one container inside one single. Yes, that is possible. But the thumb rule and the best practice says that you must not deploy more than one application within one pod. That is, one pod should contain only one container with one single application. Is that fine? In the childhood, we used to learn A for apple. We do not say A for orange. And somebody will place an apple for us to understand that this is apple, this is not called an orange. But if we had been taught from the very childhood that what you see in the shape of an apple is actually an orange, we will learn that. So we cannot, we do not usually challenge the convention. This is the convention. That is what we have learned without asking any question. So you can ask why should we always go for that? Because that has been tested, and that is the best performance throughput when you have one application in one single pod. That is the reason we have to accept the best practice, which is to have only one application within one pod. Or basically saying one container having one pod having only one container. Now coming to the replica set. as we were discussing the replica set, this is also a Kubernetes object. Kubernetes object that manages the life cycle of the pods. So if I say I want a replica set of a MongoDB pod, MongoDB is an application, okay, say a database application within one pod. I want 3 replica of MongoDB. So what will be the replica set? It will be, I'm saying that there will be 3 replicas. So the replica set object will be created with 3 replicas. That means I will have at any point of time, my desired state is 3. So I will always go for 3. If any one of the replica goes down, I will be immediately, or the system will immediately replace that pod with another one. Always making the number 3 or 5, as you have said. The given image illustrates a replica set managing 4 identical pods. So how many replicas of the same MongoDB application? There are 4 MongoDBs with the same data contained or cloned into all of these replicas. So they are identical pods. They are exactly whatever is over here is also over here. So you have done a replication of 4 identical pods. And that process is through a replication controller, and which will give you a replica set. If a pod crashes or the node it's running on fail, the replica set controller ensures that another pod is, this is a controller, replica set controller. And remember who is the manager of that replica set controller? Who is the manager? The manager is a replication controller. And what is replication? Sorry, this is not the replication controller manager. And what is controller manager? You know, that is a component of the master plane or the master node, controller manager. So sub manager, this is the boss, and this is the manager, and this is the assistant manager. Assistant manager. So the assistant manager will be called upon by the controller manager whenever there is a replication job, and therefore the replica set controller or replica set controller will be called by the controller manager, because I need a replication of 4 replica of the MongoDB. Okay, so this controller will be called, and that controller is actually, it's another set of program called replica set. And that pod is scheduled to replace it, maintaining the desired count. So I wanted 4, I will always get 4. 4 will always, we will maintain, this is the desired. And so this will always be replicated, replica set. That is it always should be maintained this particular number. If there is one shot, again, this particular pod will be replaced immediately to make it +1 equal to 4. Every time it will be 4. How does a replica set work? A replica set works by using selector. Okay, these are all coming under, can anybody tell me where, in which manifest file? Because see, you are creating a replica set of a pod. So who is creating a pod? The manifest file called deployment. You are deploying a pod, you are creating a pod or a replica set of a pod. So within the deployment manifest file, This is a configuration file of Kubernetes. This manifest file will have some code, some configuration. And in one configuration, you will see that replicas, and you say, as it's all YAML file, you will say replicas. So it is the key value. It's a YAML file. The deployment manifest is a YAML file, which will be executed by kubectl. I am repeating these sentences again and again so that it is ingrained into your mind. Kubectl will execute this manifest file over the Kubernetes cluster and be processed by the API server to create the pods. And the pods will have certain, this particular configuration called replicas tree. It can be one. One is always by default. You cannot create a pod of 0 replica. No. By default, it is 1. And it can go up, go 5, it can be 7, all odd numbers, 9. There is a logic why all odd numbers. But I do not have a scope to explain that. Okay. And similarly, there is a keyword called selector. Selector is the key, and the value will be some selector, some value. And the selector will have a sub value called label, all small letters. And within that, so it is a key, sub key, label. And then you say a label. Let's say I have made it a label as MongoDB. So what is the label of the pod? So a pod has been labeled as this one because I need a label so that I can use a service, which is another manifest file, to access this label. That means this pod of this number of replicas. So all the replicas having the pod of MongoDB will be accessed by this service. Is that concept clear? So whenever from external side you hit this service, you can reach this pod. You can reach this pod. Okay. So you are basically, the service will always relate to the deployment, and the deployment says what is the label through the selector, and the label is MongoDB, and therefore you have attached this service with a particular IP address to this particular pod. So the selector can match pods by label. These are the terms, allowing it to track pods dynamically to the service. When the number of the pods matching its selector and in the correct state falls below the desired count, the replica set will schedule new ones. As we have already discussed, whenever there is a shortfall of the count, if the replica set says 4, and if there is at present there is 3, so the kubelet will report there is 1 missing or there is 1 down. So immediately this information will go to the HCD through the API server, and API server will instruct the scheduler to schedule 1 more pod of the same label MongoDB, such that this service can now access all the 4 or the desired replica set. Is that clear? Suppose you have created 1 more than the desired. So now it becomes 5. But what is your desired? 4. 4 is not equal to 5. You desired 4. So 1 pod will be deleted. Delete the excess pod. This is again the problem of the scheduler. If you fall short or if you have excess, in case of falling short, you will create 1 more pod. If you have an excess, one pod of the same label will be deleted or removed. Now, you see, replica set is a It is an object, Kubernetes object, but now this has been replaced by a higher level concept called deployment. So we no longer use a replica set manifest file. After Kubernetes 19, after Kubernetes 1.19, we always now go for, now the current Kubernetes version is 30. Okay, so after 19 till 30, we all use deployment manifest file. We are not using replica set. Replica set is between 1 to 18. They were old version of Kubernetes. Replica set is no longer supported. It is supported, but it is much more flexible and it is having much more features than replica. So why use deployment and not replica set? A deployment is a higher level concept than that manages replica sets and provides declarative updates to pods. Now, a replica set could not do a deployment which is like a rolling update deployment or a blue-green deployment or a canary deployment. All these things are not possible if you have used pods which were deployed through replica set objects, manifest file. You cannot use a declarative updates to the pods if you are using replica sets. Therefore, we need a deployment manifest file with a lot of other features. Therefore, it is generally recommended to use deployments instead of directly using replica sets. Here is a brief comparison of the both. A replica set ensures that a specified number of pod replicas are running at any given time. However, a replica set does not support a clean rolling update. This is very, very important for you. This is an interview question. Why you do not use replica set? Because it cannot support a rolling update. A rolling update means you are deploying something into an existing system. This existing system is running, system A. But after a year, your management has said that, or it was a requirement that your system has to be upgraded from system A to system B. But you have so many users hooked into this system. There's a huge traffic because it was a very popular application and your system is being used by, let's say, 1 million users. They are all hooked into your system. Now, how will you upgrade it to a system with new features? So this is a small set of features. Here you have more features over here. Okay, that is required because you want to introduce some new things into your system. So what is the mechanism that you keep your users hooked into system A, but parallelly you deploy the new features without disturbing? You do not disturb this, but at the same time so the environment, this is a production box. Keeping the environment same, this is, let's say, blue, which is active, and this is green, which is inactive, but which you are preparing. Okay? You deploy your new features. Let this is running. Let this keep on running for the users. And here you have deployed in this cluster, in the same production box, you have deployed the new feature or the new application, new pods. And then when you have tested, they have been tested 100% fine. 100%. When everything is working fine, then what you do, in one go, you make the green turn into blue. How? You divert or redirect all the users. Now, all the users will be pointing to this system. You do not disturb this. So at the same time, there are two systems now running. The blue as well as the green, which is now the blue, because it has all the production traffic now diverted into this. There is a mechanism how you divert you just have to divert them into this system. So what will happen? Both the systems are running. Let it run for 2 to 3 days, no harm. So within 2 to 3 days, you will see that everything is fine. Your users are not coming up with any complaints. Your system is robust. They are happy. Then you turn this off, switch off this system. So now this becomes green and this becomes blue. This is not possible if you are not using deployment via the deployment object. Yes. If you had used replica sets, you were not able to do this sort of no downtime deployments. These are no down. It could be canary, or it could be blue-green deployments. This is a very, very sought after deployment scenario for our industry. For the industry, they prefer to go for blue-green because there is a zero downtime. Earlier, when I used to work with IBM, I have seen as a project manager, there we had to fight with the customers to get a 1 hour deployment window or downtime window. We can say downtime window. To get a 1 hour downtime window, we have to justify almost for a week or 2. Because 1 hour downtime is costing the business lots of money. They do not agree to this downtime. Earlier, say another 15 years back, we used to get almost 4 to 5 hours downtime. No issues. But nowadays, the competition is so high and everything is so real time that to give even 5 minutes downtime, can you think of Amazon getting down for Amazon or Microsoft getting down for 5 minutes? It happens. I'm not saying that it doesn't happen. There can always be mishaps, but generally a 5-minute downtime of Microsoft can cost them $5 billion. If not billion, at least million. So no business house will be allowing you to. So this is the best. There is no downtime. No downtime. The users are transparent that your system has been upgraded to a newer version without their knowledge, without their user experience getting okay. So this is the replica set. It was good, but it is old. This is the best, the new. A higher level concept that manages replica sets and provides declarative updates to pods. It handles declarative. You can declare, you can keep on changing the deployment. Here it is almost like sort of once done, it will be difficult to modify. Here you can keep on changing the resources, changing the replica set. This is a fantastic one. It handles updates in a controlled way. So it's in a very controlled way, providing mechanisms for update strategies like rolling update, paused update, and rollback. Yes, another thing is, suppose this was having some issues, lots of problems. Okay. After you have shifted your users, redirected the users over this, they are facing issues. What you do? You straight away roll back to the old system. That's all, because this is still running. This 2 to 3 days, or maybe sometimes they are using 7 days, or maybe 15 days, stability period. All the while, this is system A and system B is running. But maybe if the user complains that there is a performance degradation or they are not happy with the system, then you can immediately roll back to the old system. So rollback mechanism is also, and so therefore everything will be mentioned under the deployment. How do you want to roll back? Under what threshold and all these things? But this can be discussed in detail when we go through our job ready training. Very, very interesting topic. So deploying application in Kubernetes, I'm coming to this. So the deployment is the object. You see, you know this architecture, Kubernetes master and Kubernetes node, and here are the users, okay? And you are a developer or you are a DevOps guy, DevOps engineer who is working on the Kubernetes. So what will you do? You will interact with the API server or the master server through what? What is your interface to interact with the Kubernetes cluster? Can anyone tell me? What is the CLI? kubectl. You will interact with the API server, you will execute your deployment file. So this is a deployment file, a manifest file. This will create your pod. The pod, already you will define the specification of the container with the application. Application is the image. So the deployment gives you scaling, updates, and rollback specifications within the deployment manifest file. Deployment creates the pod with the replica set. How many replicas do you want? And the pod encapsulates the container, encapsulates. This is the OOPS term, encapsulates. That is embeds, embedding. These are object-oriented programming concepts. The container, and the container encapsulates the image, which is the main, the core, the component, the component you are interested with. You do not know deployment, you do not know pod, container, anything. You are from outside, you only want to access this particular application, maybe a Java application. So the deployment in Kubernetes is a controller which helps your application reach the desired state. The desired state is defined inside the deployment file, manifest file. All these definitions, configuration will be done inside the deployment file. I do not have a scope to let you know what happens in a deployment or what happens, how it looks like. So that's okay. Deployment is an abstraction layer on top of pod to achieve the desired state of the application. The desired state in terms of replicas, health checks, resources, which defines the pods to manage the pods more efficiently than individual deployments. Deployments play a crucial role in managing application deployments in Kubernetes. Yes. They provide a declarative approach to defining and managing the lifecycle of applications, making it easier to scale, update, and roll back deployments. Am I audible? Are there any people?
Yes, sir.
Oh, okay, you are there. Fine. So deployments abstract away the underlying complexities. Why you do a deployment? Because this mechanism, this architecture is very complicated. I do not want to go into any complexities. I want to abstract away and make my things very simpler. I use deployment manifest file. I desire something in my very simple way. I do not want to understand the complexities inherent within a Kubernetes cluster. That is the headache of the Kubernetes cluster itself. Why should I make my life complicated? So I will use deployment and provide a higher level interface for managing application deployments. Deployments ensure the desired state of the application and automatically handle scaling, rolling, updates, and rollbacks. So scaling means you want today there are 3 replicas. Tomorrow, as the load increases, as the interface becomes more popular, more and more user will interact. So maybe 3 replica will not be sufficient enough. So you want to scale it 7 or 9. So scaling, you just modify the deployment file and execute it. That's all that you need to do. How simple. So now coming to the service, and again, as I told you, along with the deployment comes the service, because you are deploying the pods, and the pods will have the services, needs to be attached to a service. So service is created as a manifest file. Again, that like the deployment, you have to execute it through the kubectl, and your service will be attached to a deployment through a label. So because service gives you permanent IP address, and therefore the service can manage the lifecycle of the pod and service. Lifecycle of pod and service not connected. They are 2 different objects. Pod is an object, service is an object, deployment is an object. Deployment is a abstraction layer over the pod. Pod is an abstraction layer over the container. Container is a layer on top of, or the container is an object which is like a bucket which holds the image. So they are various layers, abstraction layers, and service is not a part of this life cycle of the pod. So even if the pod dies, the service is disconnected. So the service which is having a permanent IP address does not die because the pod dies, as we have already discussed. So services ensure that even if the pod dies, the services with a permanent IP address continues to stay, and there is no need to change the endpoints. You do not have to adjust the connections between the pods. There are 2 types of services. One is the external service, and the one is the internal service. Now, did I mention? Okay. We will come to this ingress. Okay. But the external service is through node port or load balancer. This is a service. And then we will learn also the ingress controller or the ingress. So these are all external service. So you are using your browser. Okay, you will access the node port externally to get inside the cluster to access your pod. So that node port service will take you to that particular port, that particular pod, but from external. So do you think this is safer way? If you can directly access your pod from outside, is it a safer way? Using the node port, load balancer, or ingress? It is not at all safe. It is not safe. Whereas when you access through internal service, that is called cluster IP. This is the internal service, cluster IP. Okay. When you access this somehow, the cluster IP cannot be accessed directly because it is not external service. So there is a ingress controller. A nice concept. So it is like a firewall. It is like a firewall which is protecting your cluster. So only once you know how to crack this and use this ingress controller to get access to your cluster IP, your cluster IP will take you to the desired pod. Because what is the function of a service? Service is attached to pod. Each service will be attached to the pod. Yes, the service will be attached to the pod level. Okay, but you are either accessing it through the internal service or external service. But this is not safe. This is the safest. So services are used to load balance the traffic among the pods. Service is itself, this cluster IP or the node port or load balancer or ingress, they are themselves a sort of a load balancer. Load balancer service and load balancer, they are two different things. This is a service and this is a load balancer. So the load balancer means you split up the traffic. You distribute the traffic according to the load, according to the round robin logic. Round robin logic. This is an algorithm, okay, through which it will decide where the traffic has to land, in which node, in which pod. Okay, so this service, either cluster IP service or node port service, which is external service, can lead you to the healthy pods. So it follows round robin distribution among the healthy pods. So it will know through that logic definition, it knows which pod is healthier and which pod is too much busy or tainted. So the cluster or the Kubernetes will taint if there is a too much of load, too much of pressure, and this pod is screaming for resources. I want more CPU. I cannot manage that particular request. There are too much of a load. If they have attained that threshold, so this service will immediately know that this is too much loaded. So this is free or maybe not that much loaded, and this is that much not loaded. So either the traffic will go to this or go to this, but never go to this. Whether the service is cluster IP, which is internal, or whether the service is node port, external node port, or load balancer. And you are the user using your browser. Okay, you are giving some URL to reach this particular service. Once you are in this service, the service will take you to the pod, to the application that you want. So if there are no ingress controller, you will land up using the node port or external service, which is not safe. Not safe. Okay? Any question? And how would the service or ingress is another service, we'll come to know that. Know which is healthy, which healthy replicated pod the traffic has to be routed to access the application hosted in the container in the pod. It is through the pod labeling during the deployment of the pod. So during the deployment, what you have done, you have written the pod label, you have given the pod specification and given the label of the pod. So the pod has a label. Let's say this is Flipkart login. This is a login application of Flipkart. So this is a label. So these are the replicas. So do you think that they will have the same label? All the three? Yes. They will have the same login, same label. And therefore, this service was created, manifest file has been created for this service, which will only interact with this particular label, the pod label. And the pod label was created during the creation of the pod through the deployment. Clear? Any question that you may have? Now, my last topic today is understanding the ingress. You access your EC2 instance. That EC2 instance is nothing but a server, virtual server over the cloud, Amazon Cloud, AWS Cloud. So when you are coming inside, and there is a firewall, and the firewall is set with some ingress rule, that incoming rule, which are the traffic that that firewall is allowing to enter the EC2 instance. That is called ingress. And when you come out of the server, okay, that is called egress. Coming out is egress, and coming in is ingress. So the terms remain the same, but here you are not going inside a server. Yes, you are going to a server, but you are actually getting inside a Kubernetes cluster. That means the act of entering into a Kubernetes cluster is ingress, and act of going out of the cluster is called egress. So what is an ingress? An ingress is an object that allows access to your Kubernetes service from outside the Kubernetes cluster. You can configure access by creating a collection of rules. Like as I told you, the ingress rules of the firewall inside a cloud, Amazon Cloud, okay, to access your EC2 instance. Similarly, to access your Kubernetes cluster, there is a set of rules that you can create, and that is called an ingress to access your cluster. That if you obey, or if you go by that particular rule, then you can reach your service. So I am creating an ingress object, which is a collection of rules to access your Kubernetes cluster. You can configure access by creating a collection of rules that define which inbound connections reach which service. So there can be multiple services. Each of the services taking you to different pods. This service, again, this is an internal service, right? Cluster IP, as we have discussed, cluster IP is an internal service. I want to access the Netflix videos. Let's say Netflix, these are the various Netflix services, the pods. So I want to see the videos. And this is some audio service, not the video, audio service. Or maybe the news service like BBC. News service. So this is a video service, or say, let's say entertainment service. So what you do, you as a user, you want to go to your, in the same domain, in the same cluster, you want to access the Netflix videos, the particular movie. So this movie has replicas. So these are the pods labeled Terminator. Let's say the movie is called Terminator. So this is also Terminator. This is also Terminator. Okay? Any one of them, they can be scattered over various servers or called the worker nodes. This is the cluster. The entire thing is a cluster. And this is your service object, cluster IP. So how do you come to this service? You will give a request to the ingress service. Now this is a service. This is a node port, external. As I told you, there are external services by the name as node port or load balancer. See, node port or load balancer. So you will directly give a URL having the node port IP address or something like that, a port number with an IP address. Okay. So you hit this. First, you come to this. This will take you. So though it's an external port, external service, it directly cannot go to your pod. You are not reaching from here to here directly. No, there is no way because it is not safe. You should hit the cluster through some safety path. What is that path? So once you hit this, it will take you to the ingress controller, the person standing between you and the cluster. This ingress controller is called Nginx. Most popular one is Nginx, which is again a pod. Nginx ingress controller. So there is a pod running Nginx. Nginx is called a reverse proxy. Reverse proxy server, which is a pod running inside this ingress controller, which is an object which you have to install. It is like a load balancer. This is also a load balancer, but in form of an ingress controller. Why ingress controller? We'll come to that. Because this load balancer, Nginx ingress controller, will take you to an ingress object. This, we have just now learned that there is an ingress object, a combination or a collection of ingress rules, incoming rules. You are incoming. So one of the rules designed over here into this object that you have created, this is also a manifest file. This is also a manifest file like the service, like the deployment. This rule will take you to this service. So there is a path. This is the path. Okay. And this is the another path, which are all defined within this rule, ingress rule. And that object will take you to this. If you have given a path saying that I want to access devo.com/video, it will never go to this service. It will only land you up if you have followed all this path. I have given the correct node port, come to the ingress controller, and then ingress controller will take you to the ingress rule. Ingress rule will take you to that particular service. And therefore, you can watch the Terminator movie, which is one of the applications running inside the cluster. Are you getting me? This is the simplest way I can define. So the ingress object that you have created is a YAML file, manifest file. This YAML file has backend rules. What are the backend rules? The most popular ingress controller is Nginx, which can effectively route the traffic by the traffic backend rules. So Nginx being, there can be lots of other ingress controllers, but Nginx being very popular, it can route you most smoothly, interact with the ingress rules and take you to the service. And this being the internal service, that is one of the safest way. You directly not getting access. You can never get an access. You have to come through this complicated path to access your pod, because your data, this is a data, sort of information data. So this data has to be protected. And the cluster will ensure that you can never reach this service without accessing the cluster IP service. Any question? So you are giving some like /image in your URL or /video. So if you are saying /image, it will take you to the image service. So image pod 1 or pod 2 or pod 3. But if you had given the video, if you want to go by the video ingress rule, so you will hit that and go to the video pod 1 or pod 2. And this can be some other service and its port. So all these are defined within the ingress rule or ingress object. This ingress object. Is that clear? So the ingress as a whole consists of an ingress API object, which is this, the rules, and the ingress controller, this one. So a combination of ingress rules and ingress controller is called ingress. So ingress, what is ingress? So ingress object, the rules plus ingress controller. Clear? Any question? So like this is the final diagram, diagrammatic representation of ingress. So here you see, you are the user, right? You are giving you are hitting a URL and you are giving something .example.com. Let's say like the google.com. So that URL will take you. Now, this is a domain that you want to access a particular application within a domain. And that domain is DNS, Domain Name Service Registrar. Who are the service registrars to which you get your domain? Is GoDaddy, Google Cloud DNS, AWS Route 53. This is a very popular service, AWS Route 53 or GoDaddy. I think you have heard the term GoDaddy. GoDaddy is a service provider who can give you the domain. So any company who wants to have their own domain, like any big company or any small company, medium company, any company that you form, even if you have a business, if you want to create your business and you want to have your own footprint, you must buy one domain, either from GoDaddy or Google Cloud DNS or AWS Route 53. They are separate service providers. They will give you an IP address of your domain, which is unique. And give you the domain name, DNS name. You do not have to remember the IP address. The IP address will have a value, but actually you are going to use the name, the domain name given by the registrar. And that registrar will maintain your domain as DNS records. So fine. So you hit your domain. Then there is a cloud load balancer because you have gone to a cloud. The cloud will, because there are not only one user, there are millions of users using that particular domain. So they must be filtered or directed by a cloud load balancer. That is the system that has been implemented for you. That cloud load balancer will take you to the ingress controller because you are finally going to access the cluster, because in the cluster, inside the cluster, your application resides inside the pods. So what you do, you hit a node port, the ingress controller service endpoint. So, and that endpoint or the ingress controller is particular in the particular service, the cluster namespace, ingress nginx namespace. So whenever you are installing the ingress controller, your namespace is also created and your object or the ingress controller is residing in that namespace. This is done for you. So you hit that ingress controller through a node port. Remember, this is a node port. External service or a load balancer. This is a service, external service. Then that will take you to the ingress controller. Now, ingress controller is sort of also a load balancer, which will hit the Nginx pods, which is inside the ingress controller. That is why it's called Nginx ingress controller. Okay, so any of these pods. So that will take you to the ingress object. Now, ingress object is the rule, set of rules that are designed to hit a service. So you want to reach the payment application, payment service deployment. So payment application, these pods you want to hit. So you will follow this path, not this path. Suppose you wanted to go to the authentication service endpoint, auth service deployment. Okay, so you will hit the ingress, which takes you to this path. So this rule, when you hit this rule, is defined within this ingress object to the ingress controller, you will end up not here, but here. And therefore, you can access the auth service deployment or auth service, authentication service, like the login. This is a payment application, payment gateway. You want to pay, and this is what you want to log into that application. They are two different services attached to different pods. This service will take you to this. This service will take you to the other pods. Example is like you are hitting this domain, this host, apiexample.com. Then you give a path, payment/payment. So it will reach the payment service, this one. When you hit API, see the domain remains the same. Domain remains the same. But you are giving the endpoint or the path or the rule different. So the endpoint is this, auth. So it will not take you to the payment service. It will take you to the auth service, this one. So the ingress.yaml is the object that you have created as ingress rules. So this is all that I could have delivered in these 3 Kubernetes sessions. Okay. There are lots of things because if I had, there is no scope. Sorry. This is a structure of a deployment file. This is called a deployment manifest file. Can you see it's a YAML format? API version, whatever, kind is deployment. And this is very simple. If you know this, these are few commands: kubectl run nginx, image nginx, kubectl expose deployment nginx -- port 80, kubectl scale deployment nginx replicas. You want to scale up the replica from some number to now you want 3 replicas instead of 1. You want to delete a deployment by the name nginx. You can. These are all kubectl commands. Not all. These are a few commands. This is a structure of a deployment file. This is a structure of a service YAML file or service manifest file. So the kind is service. Can you see? Kind service.
Yes.
Kind is service. Here the kind is deployment. then you define the spec is the replicas. Can you see replica 3? Selector, match label, app. You have given the pod a name because you are creating a pod through this deployment. How many pods you will create when you run the deployment? It will be 3. Then you are defining the template of the container. Okay, the container name or the application is all the same. The label of the pod should always be the same. And then within the specification of the container, you are putting in Nginx image inside the container. So the image is Nginx. So you are deploying a Nginx application as a pod to this deployment manifest file. And then through the service manifest file, you are assigning a service, attaching a service to this pod, these 3 pods. And that service name is also Nginx. That's fine. The deployment name is also Nginx, but this is a deployment and this is a service. And you are attaching this service Nginx to the pod by the name label as Nginx. So they have to match because you have given the label as Nginx. So this service is attached to the Nginx pod, 3 pods.